Hello. I'm Michael. I'm half the team behind pgMustard, and I'm going to show you how to speed up a Postgres query using explain, analyze, and pgMustard together. Great. So, got a really simple example here. All it's doing is getting the top scoring Premier League games of all time. So we are selecting the games from a table of Premier League results where there were at least 10 goals, ordering those by number of goals, and then in case of any ties, the oldest first. Great, so let's run that and see if it's doing what we expect. Yeah, and you can see here in my client, I'm getting a round trip time of about 16 milliseconds. I'm going to run that a few more times, get a rough idea of how fast that is. So somewhere in the region of 10 to 15 milliseconds. So next we are going to have a look at the server-side time and the plan, the Postgres plan behind the scenes. So to do that, we're going to use explain analyze. Now this will also run the query behind the scenes, so be careful if you're doing any data modification queries. Additionally, we're going to ask for some more performance information, including cache-related information from buffers, and we're going to get that in the default text format. Wonderful. So, some of you might be familiar with this, but if not, don't worry if it looks a bit like a wall of text. This is the query plan, and you can see that Postgres is doing a sequential scan of the table, then sorting those results, then applying a limit at the end. You can see some of the timing related information, so the execution time, as well as timings on each operation here. So there are whole tutorials on how to read these, and you can imagine as the query gets more complicated, this can get quite large. But today we are going to have a look at pgMustard, which is a tool for analysing these, and to do so we're going to get a query plan in JSON format. So I'm going to request that now. Now this is what those look like. All of the same information, just structured differently. That now says 13 milliseconds. I'm going to have a quick look. We're only getting a total time of 5 milliseconds at the top there, so I'm going to run that just a couple more times to rule out any other issues. That's brilliant. Okay, so 7 milliseconds here, 7 milliseconds at the top there. Let's have a look. So copied that, I'm going to paste it in here, submit. Wonderful. So in pgMustard, you'll see any tips over here, things that we think could be an issue, as well as a timing bar. So total time is 8 milliseconds here, and these are each operation, and the width represents the total time. So you can see it dominated here by operation number 2, which is the sequential scan. The tree view here mimics the text format we saw originally. And these scores here are the best tip we have in terms of score. Those are scored from 0 to 5 based on how likely we think they are to speed up your query. Right, so let's dive into that slow operation, which is sequential scan. On that operation, we can see that pgMustard saying that there's index potential, and it's ruled out several other potential issues. So row estimates can be a problem in terms of query planning, as well as cache performance and bloat. However, these don't appear to be an issue for us today. Index-wise, the reason we're getting that tip is that only 6 out of nearly 10,000 rows are being returned after filtering. So that's a really good use case for an index, so it can look up just exactly the rows that meet that condition. And the filter in our case was the goals being at least 10. Wonderful. So we can flip back and have a look at what creating that index will do. So let's create that index on goals, which is what we were filtering on. Run that query again. Again, I'm just going to have a quick look. Looks like we're about a millisecond in total, which is a good speed up. Let me run that a few times just to make sure. Brilliant. So I'm going to copy that, flip over just to check what it looks like now, submit it. Brilliant. So 1 millisecond, we're now getting an index scan. The timing, albeit 1 millisecond, is now dominated by planning, which can happen, which is quite common in fast queries, and you'll get a nice warning here as well. You'll notice some very low tips. So we score things kind of 0 to 1 if they could make a small difference, but very unlikely to make a big difference. Let me just check what those are. Yeah, okay, so you could additionally index, do a multi-column index on the full ordering, but given that operation is a tiny percentage of your total query, it's really not going to be worth much. Brilliant. So that's it. You've seen the full journey. You can imagine on a much bigger query plan or much more complicated query, this should be able to, the process is the same, but it should hopefully save you more time. We're a tiny team. We love getting feedback. So if you have any ideas on making it better, we'd love to hear from you. And yeah, that's it. Cheers. Thanks. Bye.